a perfect angle? 2x. And we got this problem yesterday. And that's the only one you saw, so we're going to do another one. I want to make sure you understand right here that connection, because I feel like it might have been rushed. If the 0 is 2/3, let me come over here so you can really see it. If x equals 2/3, then the factor is x minus 2/3 equals 0, right? Subtract it over. But we talked about polynomials don't have fractions, so this is right, but it's not the correct format. So to get rid of the fraction, you multiply everything times 3, and those cancel, of course, over there. So you end up with 3x minus 2, and that's the factor. So that's where that came from right there. I felt like that was rushed yesterday. So had it been, say, 1/2, I'm just making this up, then it would be x minus 1/2, and then you would multiply through by 2, so it'd be 2x minus 1 would be the factor. Okay, so anytime your 0 is a fraction, that's how you get the factor to look nice and pretty with no fractions. And if you are worried that you have it wrong, don't forget what you already know from like last chapter. What's the 0 out of this? -1. What's the 0 out of this? You would set it equal to 0, add 2, and then divide by 3. So if you think you did it wrong, then just solve it, and you'll see if you did it wrong or not. You know what I mean? It should match. Go to the next problem. Here's a whole nother one we're going to do. Find the rational zeros and then the other zeros, which just means solve it all the way. And then write it in factored form. So it's a 5th degree polynomial, which means up to 5 answers. If it's a 5th degree, when I do synthetic division one time, it would then become a 4th degree. I'll do synthetic division again. It'll be a 3rd degree. I'll do synthetic division again. Quadratic, and then I can solve the quadratic. Right? There is a simpler way, and I'm going to show it to you. No, I'll show it to you from the get-go, because I think you may remember y'all remember the U substitution? Yeah. So when we do the synthetic division the one time, it'll be a 4th degree, and it's actually going to be, it's able to do U substitution, where we reduce it down to like U squared. Yes. Yes. So, and then you can solve it faster. All right, so let's start. I gotta bring it down a little. Don't write big. Y'all should know this by now. Okay, label your P and your Q. Remember, your P's and Q's are backwards when you're labeling it. Q is the very first one, and P is the last one. Then go over to the side and start making a list of all the numbers that divide into P. Don't forget your plus or minus options. Well, it's just 15, so we don't have a lot of numbers to hit. I always just start counting, because the very first one every time is 1. Then when I count, that way I make sure I don't miss one. What do you hit next? 3, then, and then, okay. Factors of Q. Q is the number 2, so we just got 1 and 2. By the way, if Q is the number 1, coefficient was number 1. Then when you go and make your list of numbers that divide into Q, it would be just number 1, which means when you go to this next step, where you write P over Q, it ends up being just the list of P's because everything's divided by 1. So those are nice when that happens. Unfortunately, that didn't happen here. No, it's just what they came up with. I don't know why, but I like to think of it as mind your P's and Q's, and then, but I don't know if that's where it was. All right, so here you go. Hold your non-writing hand to the first P, and then visualize to yourself, okay, 1 over 1 is 1. 1 over 2, just write it. Then move down to the next one. This is so you don't accidentally leave something out. All right, 3 over 1, and then 3 over 2. Just write it. Move down. 5 over 1, 5 over 2. Move down. 15 over 1, 15 over 2. And then if you remember from yesterday, the next step is now it's plug and chug. Pick some numbers to plug in and see when you get 0. And I will tell you right now, it's a fraction. There are no pretty numbers. Did you find that 1/2 works? When you are plugging these in, think smarter, not harder. When you go to check 1/2, what would be easier and less? There you go. What would be easier to type in and create less room for error, and that would be 0.5. So if there is a nice decimal, you don't like if, let's see, what's an ugly decimal? No, they're all pretty because it's all divided by 2. Let's say 1/3 was one of the fractions. You don't want to type in 0.3 because that's not actually 1/3, right? So only if it's a pretty fraction, I would type the decimal in because then you don't have to worry about typing the fraction. So you should find that f of 1/2 gives you 0, which means it is in my list of solutions. I've just found one. Which also means it's in my list of linear factors, right? F of x, so we already got the first one. What factor does that come from? So here we go again. Subtract it over, but it's a fraction. So then multiply through with the 2. What do you get? 2x minus 1. So we're kind of keeping a running list of our final answers here as we go. Okay, so now we're going to do synthetic division with the 1/2. Set it up. We don't have any gaps. remember, multiplying by 1/2 is the same thing as saying divide by 2. So when you do this in your head, you could just say I'm dividing by 2 instead of times 1/2. So we're going to bring this down, and we start. You run through it, and then I'll put it on the board, and let's see if you get the same as me. Take 10 minutes. Okay, 1/2 of 2, add, times 0, add, 1/2 of -4, add, times 0, add, 1/2 of -30. And remember, that's a checkpoint. You already know 1/2 works, so if you don't end up with 0 here, something's wrong. You either missed a gap, you multiplied wrong, you added wrong, sign wrong, something's wrong. Okay, so remember the whole concept behind this process is to get a 5th degree polynomial that is in standard form down to 5 linear factors, because then I can clearly see the zeros, right? That's the goal. Okay, so you just did synthetic division with one of the zeros. So this is now a what degree? 4th degree. It always starts one less degree. And it has some gaps. This is why U substitution is helpful here. Notice it has some gaps. The 3rd degree is gone, and the 2nd degree, no, single degree, right? 1st degree. So what I actually end up with is this. Y'all agree? How do you know when to use U substitution? When it's just the 4th degree and the 2nd degree that's there. That's when you know, oh, I could actually do U substitution here. Now, had it been 4th degree, 3rd degree, 2nd degree, 1st degree, you would have to repeat the whole process again, find another 0, do synthetic division again. Had there been either one of these in there, you'd have had to do it. U substitution only works when it's degree 4, degree 2, nothing. That's the only time U substitution works. Okay, so this is equal to 0. What do you notice about every single one of them? Let's shrink that down. You can do that. Every single thing in there is even. So I'm going to divide a 2 through the whole thing. And now I have a smaller polynomial. Now I'm going to do U substitution. Let me refresh you on U substitution. Over here, I'm going to say to myself, I'm going to let U be the expression x squared. So, like right here, x to the 4th, you have to visualize this. This is actually x squared squared, right? So when I write U squared right here, that's where that came from. If you need me to show, I'll put, and then here's an x squared. I'm just writing underneath this. I'll just write the whole thing. All right. I'm just writing that U to the 4th so that you can see why I'm fixing to write this. Y'all see where that came from? I rewrote x to the 4th as x squared squared, and then I went in and I replaced the x squared with a u. That squared comes down. There's another x squared. I replaced it with u. And now I think it's factors. Yeah. Factors of -15 to add up to -2, -5, and positive 3. Why was I able to go straight to parentheses? Because this was, well, 1. Make sure you don't take that shortcut when that's not 1. That shortcut only exists when that leading term's 1. Okay, so now I can see, all right, so the 0 that would come out of this would be u would equal, what, 5. And the one that would come out of this would be u would equal negative 3. Now you've got to go back and say it wasn't u, it was actually x squared. How do you undo squared? You square root. And then don't forget, every time you square root, the next line has 2 answers. Positive or negative. They might think, how do you take the square root of 5? You don't. You just leave it. It's just x equals positive, negative, square root 5. Now, how do you take the square root of negative 3? Well, it's twofold. One, you got a negative under a radical. That's going to come out as an I. So then it's just 3, and then you just leave it as the square root of 3. So it's going to look like this. I like to write the I in front of the radical, but MathLab does not like that. For me, it would be plus or minus I square root 3. That's how I write it, because I don't want the I to accidentally be misunderstood to be under the radical, because it's not. It never is. But on my MathLab, they want you to put the square root 3, and then be very careful to make sure that the I is after it, like not underneath. So, you went from a 5th degree to a 4th degree through u substitution to quadratics to linear. We're done. Now we just have to make our little list. So what are my zeros? Well, I found, and you could put plus or minus here, or you can actually list it out if you want to. It's up to you. I've got positive square root 5. I've got negative square root 5. I've got positive square root 3 with an I, and I've got negative square root 3 with an I. Now, how do you write factors? Well, in MathLab, they want you to list it out right next to it, like right here. They want you to list it out. I'm going to have to rewrite this because it's so crowded. Okay, so our first one was 2x minus 1. Come back up to your solutions. Just subtract it left. So what would it be? X minus square root 5. This is all they want you to type in. They don't want you to multiply it right here. When they say, tell me the linear factors, it's nice that they don't want you to try to clean it up. They just want you to show what it would look like as a factor. So what would this one be? This one right here. It'd be x plus square root 5. Now this is going to feel weird, but it's exactly what it looks like. Subtract it over. So it would be x minus square root 3. Watch your I. Be careful. I just can't stand that. And then the other one would be x plus square root 3. Watch your I. And they don't want you to go any further. That's all they want. Now, I do want to make sure you can wrap your mind around what you just did. You just took a standard form fifth degree polynomial and you factored it. Isn't that cool? Oh. You factored it.
So the U is the biggest variable that you can pull out? Like you pulled out x squared.
When you're doing U substitution, you always want to be able to write x squared. That's, yeah. Because the idea is you're taking a fourth and a squared and you're breaking it down to a squared and a 1. And so it has to be an x squared. It's got to be even. No, it only works when it's a x4 and an x squared in the polynomial. That's it. Yeah. And that's only if it will, well, no, if it wouldn't factor, you would do quadratic polynomial. But that would be really sweet. I don't think any of those pop up. So that's 4-4. We are not doing the Descartes rule of signs because it's a nice to know. It's not a need to know. You don't have to know it. In fact, I had to remind myself what it was because I forgot it. That's how unimportant. Don't tell Descartes I said that, but that's how unimportant it is.